Okay, I just presented my previous video was on how to uh, plot uh, on Excel and how to get the slope and intercept on the trend line, how to present a trend line and how to do the slope and intercept on Excel. What if you don't have Excel? What if you don't have a computer? You can do it by hand. You can do it by hand. I took the data from Physics Laboratory Manual by Loyd, fourth edition. On this is the data that is on page 6, data table 2, and I've plotted it here. You can watch the previous video where I actually have the data, but this is the blue dots are the data. You can see this is just a hand-drawn plot. Uh, the blue dots are the data. The red line is my best fit line to fit a straight line through these 5 data points. Now, uh, when we do that, what we're doing is we're getting a y equals mx plus b uh, graph where the m is equal to y2 minus y1 divided by x2 minus x1. And the b is equal to the y value at x equals 0. So it's this 0 crossing, it's the y-intercept. That's what b is called. When x is equal to 0, it's whatever this value is that crosses the y-axis. Now, choosing your y1, your x1, y1, and your x2, y2, do not, repeat, for scientific purposes, do not choose data points. Don't choose anything that's on the blue dots. Don't choose those. What you do is you mark on your best fit line a convenient uh, spot. Now, I chose the 0.5 seconds, and it looks like it crosses about 5.5 meters. I also chose the 5.5 second line. Uh, and it crosses at this blue line would be about 27.5. So I'm estimating about 27.3. This is how you do it when you draw it manually. You'll still get good data. You'll get usable data. Okay, so using the fact that x1, y1 is 0.5 seconds and 5.5 meters, and that x2, y2 is equal to 5.5 seconds and 27.3 meters, we just plug those values into the slope formula. M is equal to y2 minus y1, 27.3 meters minus 5.5 meters, divided by x2 minus x1, which is 5.5 seconds and 0.5 seconds. You calculate that out, and you get 4.36, a slope of 4.36. Now, when we did it in the previous video, we got a value of 4.487. Well, let's calculate the error, assuming that the 4.487 is the accepted value. It's the more correct value. So we're going to use that as the accepted value. So it's 4.487 minus 4.36 divided by the 4.487 times 100. That's our slope error. And it's a 2.83% error. It's basically a 3% error. That's not a large error for our classroom lab work. Now, let's look at the B value. Where is the intercept? Well, this blue line crosses at exactly 2.5, so it's a little bit above that. So it's about 3. I estimate that it's about 3. Well, our Excel intercept is 3.061. So let's with our value of 3, let's calculate the percent error, the intercept error. You have 3.061 minus 3 divided by the accepted value of 3.061 times 100, and you get 1.992. It's basically, it's a 2% error. So doing it by hand on a piece of graph paper, if you do a manual plot, I don't want it freehand. I want it on graph paper. I want to see it on graph paper. You can see when I did it on graph paper, I used my iPad. the graph paper that you get on an iPad. I forget what what uh, uh, what is my app? I use Notability. I use Notability. I think I paid about $10 for it. It's a very, very good app. But just using Notability, I hand drew the axes, and I hand drew the data and the line, and I came up with a 3% error on the slope and a 2% error on the intercept. So that's how you go about doing it, doing a manual plot to turn in for the labs. Okay, I hope this was helpful, and that's it for this video.